So guys, welcome to our channel once again. In today's video, we have here these 10 questions to answer on the topic heat energy. So guys, this video will be about thermal expansion, vapor and vapor pressure. So in short to stay till the end of this video, let's go ahead and start with the first question here. It says, which of the following diagrams correctly represents the variation in the volume of a fixed mass of water with temperature T? So guys, the answer to this question here will be option B here, because since there is variation of the volume of a fixed mass of water with temperature T, this will be a graph that has a slope that is approximately 1/273. So that's option B here. So let's go ahead and consider the next question, guys. So that's question number 2 here. It says, a solid material of volume 100 cm³ is heated through a temperature difference of 40 degrees Celsius. Calculate the increase in the volume of the material if its linear expansivity is 2.0 times 10 to the power of -6. So guys, we'll have that linear expansivity alpha is equal to delta V over V delta T. So where delta V is the change in volume, delta theta is the change in temperature. So guys, the change in temperature is given already to be 40 degrees Celsius. The change in volume is not obtained here, but we have the volume V. So we also have the linear expansivity alpha. So let's replace this by their corresponding values. So this will be that 2.0 times 10 to the power of -6 is equal to delta V over V, which is 100 here, over 100 times delta theta. Delta theta is 40 degrees Celsius here, so 100 times 40. So guys, if we make delta V the subject of this equation, delta V will be equal to the alpha times delta theta times V. So in that case, we'll have 2.0 times 10 to the power of -6 times 100 times 40. So let's go ahead and calculate this and see what we have here. So that's 8.0 times 10 to the power of -3, and that's option B here, guys. So let's go ahead and consider the next question. So guys, the next question here is question number 3. It says, which of the following equations shows the linear expansivity and cubic expansivity of a material are related? We have A, gamma is equal to 1 minus alpha, B, gamma is equal to alpha, C, gamma is equal to 2 alpha, D, gamma is equal to 3 alpha. So guys, the answer to this question is option D, gamma is equal to 3 alpha. So let's go ahead and consider the next question. So that's question number 4 here. It says, the linear expansivity alpha and the cubic expansivity gamma of a material are related by the equation A, gamma is 2 alpha, B, gamma is 3 alpha, C, gamma is alpha, D, gamma is 1/3 alpha. So guys, the answer to this question is option B, gamma is 3 alpha. And that's it for this question. Let's go ahead and consider the next question, guys. So guys, the next question here is question number 5. It says, a cube made of a metal of linear expansivity alpha is heated through a temperature theta. If the initial volume of the cube is V, the correct expression for the increase in volume of the cube is. So guys, let's first of all recall that the cubic expansivity is 3 alpha, that's gamma is 3 alpha. Then let's show the expression of the cubic expansivity using 3 alpha to replace gamma. So that's 3 alpha is equal to delta V all over V naught times theta. So in that case, delta V, which is the change in volume, becomes 3 alpha times V naught times theta. and that corresponds to option C here. So option C is the answer to this question, 3 alpha v naught theta. And that's it for this question. Let's go ahead and consider the next question, guys. So guys, the next question here is question number 6. It says, an aluminum rod of length 1.8 meters at 10 degrees Celsius is heated to produce a difference in length of 0.007 meters. Calculate the temperature to which it is heated. So guys, in order to solve this, using that alpha is equal to delta L over L times delta theta, we have that alpha L delta theta is equal to delta L. So the change in length here is already given to be 0.007, and then the alpha, which is the linear expansivity, is already given to be 2.3 times 10 to the power of negative 5. The length here, which is the initial length here, is already given to be 1.8 meters, and then the initial temperature as well is given to be 10 degrees Celsius. So we can substitute all here, and then we'll now find the final temperature. So in this case, we're going to make delta theta the subject of this equation. So if we make delta theta the subject of this equation, delta theta becomes delta L over L times alpha, or let's say alpha times L anyways. So in this case, delta theta is equal to 0.007 over 2.3 times 10 to the power of negative 5 times 1.8. So since we have one of the temperatures, which is the initial temperature, so remember that delta theta is final temperature minus initial temperature. So in this case, the final temperature, let's say theta sub F minus the 10 degrees Celsius, will give us 0.007 meters over 2.3 times 10 to the power of negative 5. So it means that theta final is going to be 0.007 over 2.3 times 10 to the power of negative 5 times 1.8, all plus 10 here. So when we calculate this, we're going to have 179 degrees Celsius, and that's option B here. So let's go ahead and consider the next question, guys. So the next question here is question number 7. It says, a brass rod is 2 meters long at a certain temperature. Calculate the linear expansion of the rod for a temperature change of 100 Kelvin. Take linear expansivity of brass as 1.8 times 10 to the power of negative 5. So guys, using the equation that alpha is equal to delta L over L delta theta, so we have in this question alpha given to be 1.8 times 10 to the power of negative 5. Then we have L, which is 2 meters, and then we have the delta theta, which is 100 Kelvin. But we don't have delta L, so if we make delta L the subject of this equation, we're going to have alpha times L times delta theta. So in this situation, we're going to have 1.8 times 10 to the power of negative 5 times 2 times 100, and that will give us 0.0036 meters. So option A is the answer to this question. Let's go ahead and consider the next question, guys. So the next question here is question number 8. It says, the magnitude of the expansion or contraction of a substance depends on the I temperature change, I, nature of the substance, I, size of the substance. So we have A, I and I only, B, I and I, C, I and I only, D, I and I only. So guys, the answer to this question is option B here. The magnitude of the expansion or contraction of a substance depends on the three parameters: temperature change, nature of the substance, and size of the substance. So that's it for this question. Let's go ahead and consider the next question, guys. So that's question number 9 here. It says the anomalous expansion of water occurs in the range. So guys, this is one question you should always take note of because you often see it in your WAEC physics, and that's option D here, 0 degrees Celsius to 4 degrees Celsius. That's where the anomalous expansion of water occurs. So let's go ahead and consider the next and last question, guys. So that's question number 10 here. It says a metal rod of length 50 cm is heated from 40 degrees Celsius to 80 degrees Celsius. If the linear expansivity of the material is alpha, calculate the increase in length of the rod in meters. So guys, let's go ahead and calculate this. So using the formula, alpha is equal to delta L over L delta theta. So here delta theta is 80 minus 40, and that's 40 degrees Celsius. So the length here is 50 cm, which corresponds to 0.5 meters. So in this case, we are going to just plug in the values here. We don't have delta L, so delta L, we are looking for delta L, and then the delta L is going to be alpha times L times delta theta. So that will be 0.5 alpha times 40. So guys, when we go ahead and calculate this, we are going to have 20 alpha, and that's it here, guys. Option A is the answer to this question. So this is where we end this video for today. If you enjoyed this lesson, please give it a thumbs up. Don't forget to subscribe to this channel if you're not yet a subscriber. Also, if you have any specific question regarding this video, you can drop your question on the comment section below, and we'll ensure to give you a response. So finally, guys, we want to encourage you to join our YouTube channel community. You can join this channel community by hitting the join button below, and we'll see you right there. Thank you once again for watching this video, and see you on the next one.